Great. So Ethereum in 30 minutes. So this is a presentation that I've given at, I think, basically every single Devcon since launch, though I think what's interesting is how as Ethereum, the ecosystem, changes, and as Ethereum, the protocol changes, as the times change, the contents also end up changing quite a bit, right? So if you go back to the equivalent of this from 2015, you'll hear a lot about uncle blocks. Of course, uncle blocks are a feature of proof of work. Now we have proof of stake, and so we don't have uncle blocks anymore. Now, Ethereum also, of course, now has layer 2s, and back in 2016, this would not contain layer 2s at all, and now, of course, as we know, layer 2s are half the story, right? So Ethereum is, above all, an evolving ecosystem, and the contents of this are going to keep changing as the technology changes and also as the emphasis of the ecosystem changes from building basic infrastructure to now also really putting a huge amount of focus on the applications. So what is Ethereum? So first, Ethereum is the world computer. So who here remembers Ethereum being the world computer? So, this is the place where I'm supposed to put that meme where there's the guy with the gun in space saying "always has been," but I don't know. I never understood why giving someone such an amazing and beautiful revelation is supposed to come at the same time as shooting them in space 20,000 kilometers away from home. And so, I'm not going to do that today. So Ethereum is the world computer. It always has been, always will be. So in addition to this, Ethereum is an incredibly large and diverse on-chain economy. Fortunately, Josh, right before, one skipped before me, made an incredibly good presentation talking about all of the different aspects of the economy. And also, Ethereum is an incredibly large and diverse global community. And Aya and Josh and the automated intro thing before that, I think, did a really good job of showing that too. So Ethereum is many things, right? I think they're also probably you're supposed to put up a flashing sign saying ETH is money as well, but Ethereum is a lot of things, right? And Ethereum is all of these different things at the same time. So how does the world computer work, right? So the way that I think about this is layer 1 is the trust machine, and layer 2 is the GPU, right? So the layer 1 of Ethereum, that is the core Ethereum blockchain, this is the anchor that keeps the rest of the ecosystem safe and holds the rest of the ecosystem together. Layer 1 is the reason why layer 2s are able to trustlessly talk to each other, and at least once everything upgrades to stage 2, you will be able to take an asset issued on Optimism and then move it and hold it inside of a smart contract on Arbitrum and do so with zero counterparty risk. Layer 1 is not there to be ultra fast. It is not there to do 1 million transactions per second. Layer 1 is first and foremost there to be decentralized, to be robust, and to be something that is dependable. Layer 2 is the GPU. So layer 2 is all of you in the room who are part of any single layer 2. Who here is part of a layer 2? Yay, who here has used a layer 2? Who here has used layer 1? Good. We're all users here. So actually, there's lots of these different GPUs, right? And Ethereum, the world computer, is able to hold together because each and every one of these GPUs is connected to the trust machine through optimistic proof systems, zero-knowledge proofs, snarks, starks, Binias, Jolts, Plonk, Spelunkamadunk, whatever the buzzwords are, right? And all of these systems actually ensure that layer 1 is able to trustlessly verify what is going on inside of the layer 2s, and layer 2s also are able to trustlessly read what is happening on layer 1. So there's an important interplay between these two components, and together they make up the Ethereum that is here today. So what is the L1? It's a chain. It runs proof of stake. It doesn't afraid of anything. So so what does this mean, right? So Ethereum layer 1 is a chain that has existed altogether for more than 9 years now, and it's existed in its current proof of stake form for a little bit over 2 years. And I think one of the really important things for a base layer to have is you want to have clear evidence that you're building on a base layer that is decentralized, that is open, that is robust, and that is likely to keep those traits going forward into the future, right? And one part of that, of course, is something that is slow to change, right? One part of that is being something that is not suddenly going to wake up on a Tuesday, have new management, and then suddenly decide that it's just totally going to start deleting a whole bunch of different applications, change its entire model, and do other, push the fees up by a factor of 10 and do other things without warning. Another part of decentralization and resilience is actually recovery, right? So whenever a problem actually starts to arise, actually be able to recover from it and have some way of actually improving the qualities of the layer 1 over time. So over here, this is on the left a chart of Bitcoin proof of work mining pools, and on the chart on the right Ethereum proof of stake mining pools. Actually, I'm deliberately being generous here because putting Bitcoin proof of work mining pools, because before the merge, actually, Ethereum proof of work was even more concentrated than this, right? And so what we see here on the right is you see actually a pretty diverse different set of staking pools. And if you zoom into either of the top items on the chart, on the top left, so Lido, and it has somewhere a little bit under 30%, but then actually Lido is it's not one actor, right? It's a DAO. Technically, the deposits are split between 40 different node operators approximately, and there's some more complicated structure that keeps updating. So I think it's reasonable to think of it as being somewhere between 1 actor and 40 actors. Exactly where, this is a problem for you social science people to figure out, right? How do you actually quantify the decentralization thing? There's even grant opportunities for this stuff. So that's that's number 1, right? And then number 2, unidentified. Now, unidentified is not an actor, just like there's the any key on your keyboard is not actually a key. So unidentified, we actually don't know what it is. There's probably lots of solo stakers, lots of small business stakers, lots of various tiny staking pools, also not one actor, right? So Ethereum L1 today actually has a surprisingly high degree of decentralization in its proof of stake design, and this is a property that I think has only gotten better over time. Here is one property that actually has gotten a lot better. So Ethereum, about 5 years ago, was basically just Geth, right? And when you have an ecosystem that is dominated by one client, that itself becomes a central point of failure, right? So who here remembers the 2016 DOS attacks? Yay! So, remember, wake up 5:17 a.m., get a military-style wake-up call, say, hey, you have to go down to, the thing that we suddenly turned into a war room now. Go down, and then, oh, someone discovered a bug in the client. Now the entire chain is stopped, and then we fix it. And then 2 to 3 days later, some guy somewhere finds another bug, and then 3 days later, another bug, and then that keeps going on for a whole month until eventually we have to hard fork. But during that period, actually, the ability for Ethereum to have 2 different clients, at the time they were Geth and Parity, basically saved the chain. There were times when there was a bug that would hit Geth but not Parity. There were times when there was a bug that would hit Parity but not Geth. So Ethereum actually gained a lot from having multiple software implementations, and this is something that, as of 2024, is probably at the best that it's ever been in Ethereum's history. So, okay. So on the left, you have consensus clients. Consensus clients handle the proof of stake part of Ethereum. On the right, you have execution clients. Execution clients handle the EVM part of Ethereum. So as we can see, the single client with the highest market share is Geth, which is like somewhere around 50%. And actually, this is from a source that's basically assuming that most unidentified clients are Geth, and so it could easily be below 50%, right? So let's say it's about 50. So what happens if there is a bug in any Ethereum client, like literally today, right now? Okay, anyone here has like a bug? Okay, Josh, can you check, is Ethereum still running? I'm gonna guess it is. But, bet like 99.99% plus on Polymarket. Okay, so case one, what happens if the client is Geth? That's the worst case. If the client is Geth and there's a bug, what realistically happens? Basically, chain splits in half. One half follows Geth, one half follows the other clients. But on both sides, the chain stops finalizing. To finalize, you need 2/3. If you have less than 2/3, the chain keeps going, blocks keep getting created, but the chain stops finalizing. And so if you are a user, an application, a business, and you're waiting for confirmation on some transaction, you're probably actually going to be waiting for finality. And so if the chain splits in half because of a client bug, well, actually, neither chain is going to finalize, and so you're going to detect that, and you're going to be on standby. What's realistically going to happen? Core devs get on high alert, figure out which client actually has the bug, and the bug gets fixed. The one time this happened in Ethereum, actually, fun fact, I actually set the transaction that did it myself. This was back in 2016. Basically, everything was fixed within 12 hours. So that's the worst case. Every other case, basically, if Prism and Lighthouse have a bug, all that happens is that Ethereum stops finalizing for like about a day at most, and then it just goes back to normal. Any other client, you're not going to notice anything at all. So in terms of practical decentralization, having multiple clients is extremely helpful. And also having multiple clients is extremely helpful because it diversifies the power and the control over the Ethereum ecosystem, especially in any kind of contentious situation, right? If some kind of DAO fork type incident happened again, and one particular development team made a choice that is unpopular, then even if that one development team just insists on pushing it through, users are going to be very easily able to just switch to the other clients and just completely route around them. This is not something that is anywhere close to that practical in a single client ecosystem. Having a diverse multi-client ecosystem is actually very difficult to achieve. I think aside from Ethereum, no other chain has really achieved anything close to this. And even outside of Ethereum, like even web browsers supposed to be an open standard. Reality is like something like 80% of the plus of the ecosystem, probably even more, runs on some fork of WebKit, and the rest runs on Firefox, which is kind of valiantly trying to hold its own as an alternative and is doing pretty well. It's one of the browsers that I use. But like you can see, right, like there are natural pressures toward homogenization and toward one implementation winning, and Ethereum actually has managed to buck this trend. So in Ethereum, 2 years ago, this chart was worse. And so Ethereum's decentralization is not only able to not get worse, but it's also able to actively respond to problems that exist and over time push to make them better. If you're building an application that you needed to exist 5 years from now, 10 years from now, and that you want to be robust and continue working 5 or 10 years from now, what properties do you want the chain you're building on to have? I think properties like these are exactly what you would be looking for. With 32 ETH, or with less than 32 ETH if you join a pool, there's more and more really interesting pool options that are appearing. There's even things like O-ball squad staking, there's options around, okay. there's options around like basically creating smaller pools with your friends. There's different pools that follow all kinds of different rules. And so there's lots of different ways for you to become a staker. And if you're a staker, then you become part of this network of nodes that is securing the Ethereum blockchain. So earn rewards while securing Ethereum. So I guess this is how the foundation propaganda describes it. It has a cute elephant. So good cheers for the elephant. So you too can join the network and you too can help secure it. So also, even if you're not a staker, you can also run an Ethereum node and you can verify the chain. So this is a computer. I mean, I guess these days nobody even has desktops that look like this, right? It's like you either have laptops or you have like some crazy like GPU construction that's like basically like looks almost like a server, right? But like I don't know. I mean, I just like shoved like a desktop computer into Stable Diffusion 3.5 and it like put this out. So that's the computer you get. You too can run an Ethereum node on your computer and you can verify the Ethereum chain, right? So this is really important because if you have users that are verifying the chain, then even a majority of the stakers acting together, even 2/3 of the stakers acting together, are not able to change the rules on people without everything breaking, right? There's the Ethereum rules, they can only change through a hard fork that is agreed upon through wide community consensus. They cannot be pushed through by a majority or supermajority of the stakers. And this is something that is really key and really important and makes blockchains very different from almost any other kind of protocol. And I think this is one of those things that's really valuable and really important to preserve. I think even among blockchain ecosystems, it's basically Bitcoin and Ethereum that really have a strong culture of like real, at least among the large ones, right? Of actually trying to make it possible and keep improving people's ability to verify the chain. And there's a lot of protocol upgrades that are coming that precisely have the goal of making it even easier to verify the chain. So today, you have this. Tomorrow, you will be able to, one, run a node without requiring more than a small amount of storage using stateless clients. So this is in my big like series of 6 posts. This is going to be the one on The Verge, right? So stateless clients is a very important section. Light clients. So there is a project called Helios, which is doing a form of light verification of the chain. So light verification is not perfect. It still follows the consensus. And so if 51% of nodes change the rules, you are going to follow them. But it does mean that if you're using a light client, then you do not have to trust an RPC node to tell you any kind of information about the chain. And so Helios is building a light client for Ethereum that does verification of the proof of stake part of Ethereum, and also actually starting to build light clients for L2s as well. The longer term future, of course, is we want to snark the whole chain, and once we snark the whole chain, you will be able to verify the Ethereum rules on extremely large or extremely tiny hardware. So node running requirements and pushing those down is a key part of the Ethereum roadmap going forward. Also, staking with less ETH. This is one of those very active research requirements, right? So 32 ETH, it's still high. And it's even higher than it was 2 weeks ago. But no, okay. But I think like I would like for people to be stakers with 1 ETH. And so I think there's different ways to do this. There is Orbit, there is just making a large number of aggregation improvements, but there's a lot of protocol improvements that are coming specifically in order to make staking easier and more accessible, and to make running a node that verifies the chain easier and more accessible. So what runs on the Ethereum L1? So some high-value application use cases. So a lot of high-value DeFi runs on L1. ENS is currently on L1, though it's increasingly doing more and more with layer 2s. Then a lot of various applications, all kinds of things in every category. People just hold assets on layer 1. So lots of high-value application use cases on layer 1. Also, managing block roots and state roots and proof systems for layer 2s. Layer 1 is the thing that secures layer 2s, cross layer 2 operations. Layer 1 needs to still be powerful enough to handle a lot of things happening, especially in the case where a layer 2 fails. The difference between a layer 2 and an independent chain is that even if your layer 2 gets 51% attacked or 91% attacked or the team shuts down, layer 1 still stands there to protect the users. Users are able to prove their assets and their ownership and their state inside of the layer 2 and migrate it back down to layer 1. In order for this to actually be possible, layer 1 needs to actually be powerful enough to handle the load if a layer 2 actually does fail. Recently, there was a live experiment of this. DYDX v3, I believe, shut down recently, and the L2Beat people actually wrote their own implementation of escape hatch software, and so without any involvement from the DYDX team, users are able to take any assets that they have inside of DYDX v3 and bring it back down to the Ethereum L1. So, layer 2s are not just multisigs. The ability to actually move your assets out of the layer 2 and back to layer 1 if the layer 2 fails without the layer 2 team's involvement is not just theory, it is reality. So, okay, L1 runs some applications, and L1 protects the L2s. What do the L2s do? L2s provide speed and scale. So on the left here, you have a chart of like basically the same as the chart that Josh showed earlier, basically layer 2 fees, and this is just what they've done this year. So this year, layer 2 fees have gone down from about 50 cents to less than 1 cent. So this is a massive change, right? This basically means that for an incredibly wide class of applications, Ethereum has overnight gone from being basically unaffordable to being completely affordable. So that's fees. Now, transaction inclusion times, right? So who here remembers the experience of sending a transaction and then having to wait some arbitrary number of minutes, could be 10, could be 40, could be 90, for the transaction to get included? Who here remembers having this experience in Ethereum? Who here remembers having this experience in Ethereum in the past 6 months? So Ethereum has improved massively. Now, this is actually a pretty linear progression that we've had all the way since the beginning, right? So Bitcoin, 10-minute block times, and Bitcoin has this thing called a Poisson distribution that, of course, Ethereum also had during the proof of work era, but then we decided we don't like fish, and so we switched to proof of stake. So Bitcoin, average block time, 10 minutes. Often you have to wait up to 1 hour. Now, in Ethereum, the average block time is 12 seconds, but then there's still this annoying phenomenon where if you send a transaction and you get unlucky with the gas price that you set, maybe you would have to wait 10 minutes or 20 minutes accidentally. EIP 1559, which came in 2021, basically solved that and created a situation where you're able to reliably send a transaction and expect to see it included usually within 1 block. And then the merge, because of this interesting quirk of mathematics, even though the average time between blocks reduced only from 13 seconds to 12 seconds, the average time between you sending a transaction and your transaction getting included in a block reduced from a little bit more than 13 seconds to a little bit more than 6 seconds. So math problem, figure out why this is true. It's actually a really fun fact. So post-merge, basically it goes down to about 6 to 30 seconds. And then finally, with layer 2s, you have pre-confirmations, and you have layer 2s that are fast enough to just confirm your transaction within a couple hundred milliseconds. So layer 2s provide speed, layer 2s provide scale. And the way that you as a user see scale is you get to be part of an application where lots and lots of things are happening, and at the same time, your transaction fees get to continue to be cheap. So history of Ethereum, right? So November 2013, the white paper. July 2015, the launch. Around 2018, that was the time when Ethereum settled on its approximate design for proof of stake and data availability sampling. So the original papers and like documents for data availability sampling and erasure coding, I wrote those back in 2017, and then we settled on the Casper, the friendly finality gadget, also at the end of 2017. Actually, if you really want and you can dig, I think it's like either GitHub Ethereum Research or like GitHub Ethereum Simple Casper. You just like search for the directory called Simple Casper, and you can find like contracts written in Serpent. Like, who here remembers Serpent? Okay, who here uses Serpent? Good. I think Python is really beautiful, but I think if you want that, then you should code in Viper. Viper is actually like great. It's actually kept improving quite a bit for the last couple of years. So we had basically okay, yay, clap for Viper. Okay, and so in 2017, actually, we attempted to like basically do this like full like abstraction thing and even write the proof of stake logic directly as a smart contract. And so there's this like really fun demo that we launched at, I think it was actually like 23:20 Bangkok time on December 31st, 2017. And like, we wanted to get something out before New Year's, but then like the demo actually, it ended up like breaking up pretty quickly. It was early days. But since then, of course, it's not early days anymore, and at the start of 2018, a really massive effort started to actually build out the Ethereum proof-of-stake system and to build out the Ethereum scaling system, which has since then turned into the blobs that we have today. 2022, the merge, switching from proof-of-work to proof-of-stake. 2024, the surge part 1. Right, so if you look into the roadmap diagram and you look into the surge section, you see that there's 2 milestones. There's one that I call basic roll-up scaling, and there's one that I call full roll-up scaling. And basic roll-up scaling basically says you need major layer 2s to hit stage 1, and you need blobs to exist. And so 2024, we actually hit that. The next step is having actual like fully running data availability sampling and major layer 2s hitting stage 2. So I think that'll happen, and I think that'll happen sooner than people expect. And it's up to the layer 2 teams to actually build this. Now, future of Ethereum. There are still a lot of problems that are left to solve. So we want upgrades to decentralization. Who here wants Ethereum to be decentralized? Who here wants Ethereum to be centralized? Okay. Okay, so one person wants Ethereum to be centralized. Okay. Censorship resistance. Who here wants to censor Ethereum? Okay, a couple more hands. Quantum resistance. Who here wants Ethereum to break the first time a quantum computer comes out? Okay, one hand. That's good. Maybe it's like, sometimes like you need collapse in order for renewal to happen, right? So further upgrades to make sure that decentralization, censorship resistance, and quantum resistance continue happening. Progressive upgrades to efficiency and scale. So layer 2, I think, is going to scale extremely quickly, and its safety is going to improve quickly over the next few years. And also, I expect progressive upgrades, cautious upgrades, but still progressive and definitely ongoing upgrades to layer 1 capacity in different forms as well over the next years. And I think one of the big reasons why we need to do this, one is to support the activity that continues to happen on layer 1 itself, and 2, because ultimately, if something breaks on a layer 2, layer 1 still needs to be there to be as a backstop. And so the maximum theoretical safe capacity of L2s is proportional to the capacity of L1. We're going to have upgrades to data availability sampling to increase the number of blobs that Ethereum can support. As of about a week ago, Ethereum is actually hit price discovery mode, meaning in terms of blobs, meaning that the number of blobs that is actually being used on Ethereum exactly equals the protocol set long-term target. Now, we need to scale this number. Upgrades are happening to actually do this. So upgrades to data availability sampling. We have also scaled enough that a wide variety of applications are possible. ENS, consumer payments, social. One category that I think is going to be extremely important over the next decade is mixed financial and non-financial applications. Applications that make use of the power of finance, but ultimately to serve ends that go beyond financial goals. And I think there's lots of very powerful applications here, and I think we've spent a long time making the technology better, and we will continue doing this, but it is at the level where now is the time to build. Thank you.